My name is Chris, and today I'm not going to talk to you about Chisel itself, but rather the reasons why we have created Chisel inside Canonical. I wanted to understand the motivation behind it. To understand why we created Chisel, we first need to talk about security in the context of containers. Now, just looking back at the past few years, we can see that a lot of vulnerabilities have been added to the NVD database. Now, we are expecting that number from the previous year to be exceeded. But what does it matter for your containers? Now, when we do containers, we are just packaging software inside a sort of software unit that you can ship around different working environments, and then you can run with your container manager like Docker and so on. But essentially, you are still putting your application inside container image plus any additional dependencies that you may need. But because this is a very easy and accessible practice nowadays, we have plenty of tools to build container images. Sometimes you just end up adding more stuff than what we actually need. Whether it is because you are just inheriting an existing base image that brings generic content and you don't get rid of that, or because you just want to add stuff to be conservative and make sure it works and then don't care about removing anything else that is unnecessary for the runtime. So what that means is that you might end up with an image that is actually full of software that is useless but vulnerable. And this is where distroless, at least the concept, came into place to try to rescue such cases. So distroless was sort of kind of conceived by Google, and kind of the idea is that you want to package your application inside a container image, but just the application in its runtime dependencies. And the keyword here is runtime. You don't want build dependencies, and you don't want additional distro utilities that you'd find on your normal OS-based image, right? You just want the application and whatever is necessary for it to run when you deploy it. So that's distroless. Now, this is like a double-edged sword, right? There's the fact that containers are easy to build, and there's the fact that if you want to go distroless, doing a container the right way is very hard to master. It's like a craft that is very hard to master, because if you're going to go down that path of trying just to have your application in your runtime dependencies and therefore being distroless, today you might end up using specialized builds, specialized tools. You may need to have a lot of deep distro knowledge, because you are going to end up cherry picking the things that you need versus the ones that you don't need, which means you need a lot of knowledge, a lot of know-how, not just about your application, but how the underlying distro that you are trying to get sort of rid of, how it works. And then it's also error prone, because in that process, which typically is top down today, you are ending up choosing what to include in your final stage of the build or your final image. And by doing so, you might either intentionally or unintentionally leave out stuff that is critical for the image to run, or critical for the image to be scanned by third-party tools that will tell you what's wrong with your image at runtime. And you might also be including stuff still that you actually still don't need, just by mistake. So it's a very error-prone process that might not lead you to the end goal, to the end result that you were looking for. So to kind of reflect the problem in a nutshell, there was a sort of report issued a few years ago where the main goal was to basically take 20 of the most popular application images in a popular registry and then scan those images through 6 different scanners. The thing here is that all of them reported differently. So this was already a sort of surprising result. Well, maybe not so surprising, but it is a sort of undesired behavior that each scanner will tell you something new. And amongst many different false positives and lack of precision, whatever, the thing that strikes me as being the most concerning thing, in my view, is that at least one of those tools failed to report vulnerabilities, kind of 16 plus vulnerabilities per container. So these are the false negatives. That means that there was at least one tool that in mass failed per container to see bad stuff, to see vulnerabilities that were there. So there were hidden spots. If you were using that tool against your application image, you'd have a lot of blind spots, what's called false negative. And amongst many cases of why different scanners behave differently, maybe because the images are based on different ecosystems, different types of applications, and scanners are more supporting of one case versus the other, The underlying reason that kind of usually takes us to have blind spots is because scanners rely on metadata and information that we give them. Right? Inside our images, we have metadata. As an example, for Ubuntu images, we have a dpackage/status file, right? And scanners will use that information to understand, to detect the software components that you have put inside your container image. If we fail to put that metadata inside, scanners will just report nothing or fail to report information about a certain component that could not be detected, right? And that causes false negatives. As a very simple example here, I'm just showcasing how you could do this intentionally. You shouldn't, but sometimes you might do it unintentionally, as I mentioned before with the distroless practice. If you are kind of cherry picking things from one stage to your final image, you might forget to include such data, but you could very easily do it, again, intentionally, by just taking an image that is known to be well informed and well represented in terms of metadata, and scanners can scan it. So it's our Ubuntu image in this case. And I'll just remove the depackage status file from inside, repackage that as a new image, push it to Docker Hub. Docker Hub will run a few scans. It has Docker Scout in there. And I also ran the scans with a couple of different tools. No names here, no need. All of them just say 0CVs, unfound, because there's not metadata inside. The scanner might complain about it. They might say, "Oh, I'm not sure. There's a warning there. I couldn't see too much software here because I don't see that file." But still, it says 0CVs, and that's just wrong. That's a bunch of false negatives. So that's kind of the false sense of security that I wanted to talk to you about, and the main motivation behind Chisel. It's kind of this fallacy of being complacent with just, oh, it's distroless. It isn't broken, so I don't need to fix it. It just runs just fine and it's okay. And because it's very small, it's distroless, and it must mean it's secure. And that's not the case. That's the false sense of security. So this is where Chisel comes into place, right? The typical distroless way is to go top down. You inflate a base image or a reference image, and then you kind of cherry pick and trim it down to have a final stage with a runtime image that you want to, just with your application and its dependencies, but maybe not enough metadata, or maybe additional stuff that they still don't need. Versus the Chisel way, which is kind of going in a managed style, very much like a package manager, from the bottom up, right? You start from scratch and you ask Chisel to manipulate Ubuntu packages the same way apt would, but to do it on a empty file system. And instead of bringing all the packages to you, just bring portions of those packages to you. So you are going one step beyond distroless by only having what you need at runtime, plus only having from those packages the sub portions, or let's call it slices, of those packages that you need, that you know that you need at runtime. And this is kind of the overall picture. On the left side, we have our typical relationship between Debian packages, where you have dependencies, but Debian packages themselves can be compartmentalized. You could say that I have a library package here, I have a sort of utilities package here, and even inside a package, some files have different purposes. Like I have man pages, I have libraries, I have binaries, I have certain modules that are just for, let's say, mathematical computation, or some libraries that are just for graphics, you know? So you could create what we call slices out of all of that, and you can still depend one slice on the other. You can create these relationships as you would do for a Debian package. So on the right side, you end up with a sort of new declarative distribution of slices of packages, not the whole packages. And that's what you will install with Chisel. So you get portions of those packages instead of the whole thing. And therefore, you end up with a slice of Ubuntu, not the whole Ubuntu. And that's kind of going one step beyond distroless. So that's pretty much it. Again, not going too deep into Chisel, but the point here is that it's still Ubuntu. It's the same software that you would install through apt, but it's minimal, right? You actually get a slice of Ubuntu. You're not getting the whole package. And we still support everything that Ubuntu would. Like Chisel will support Ubuntu Pro, and the resulting software will have the same support commitments that you would find on a normal Ubuntu distribution. It's managed because it acts very much like a package manager. You are just building from the ground up instead of building on an existing file system. And it's traceable. Actually, Chisel produces the metadata called the Chisel manifest that scanners and SBOM generators can use to kind of infer what's inside your Chisel file system and what CVEs might be there. And that's pretty much it. So thank you for attending, and I'll see you the next time.